Hello, this is Mr. Stansbury. Welcome back to part 2 of chi-square goodness of fit. Okay, on this here, we just wanted to go over, there's another little bit different way to look at some of this, and that's with a critical value. So we can also perform a goodness of fit test with a critical value, which will give you a specific p-value that will equal the significance level. Okay, so basically, if you look here, it's all the same thing here except for our significance value 0. Well, depends on, normally it's 0.05, but what we're going to do instead is we're going to put in the critical value into this spot here instead of the significance level. So we're just going to swap out, put in a p-value in for the significance level instead. Okay. Easiest way I think to take a look at that is to do an example. All right. Internet Service Provider, ISP, conducted a survey asking their customers how satisfied they were with their service. They found that 5% responded very satisfied, so forth and so on here. To improve customer satisfaction, ISP made several changes to their internet plans they offered. They then repeated the same survey 6 months later, and the results are shown in the table over here. Conduct a chi-square goodness of fit test using a critical value and a 1% level of significance to determine whether the ISP changes were effective. Okay, I rearranged this so that we can get our chi-square goodness of fit test procedure with critical values table on here because I couldn't fit it all in. So I just moved the data up here. Got rid of our question down here, which basically the important part in there is that we want to go through and do a chi-square test to a 1% level of significance. Okay, so step 1, state the null hypothesis and alternative hypothesis. So HO is going to be that everything is all good. Okay, so it should be that all of these are going to be pretty close to this, to the same percentages. Okay, so just wrote it out. Probability of very satisfied 5%, satisfied 25, neutral 41, dissatisfied 20%, very dissatisfied 9%. Okay, so then our alternative hypothesis is going to be that at least one of those percentages is not going to hold true for that. Okay, so we can write it like this. At least one of the probability of very satisfied is not 5%, satisfied not 25%, neutral not 41%, dissatisfied not 20%, or very dissatisfied not 9%. Okay, so that's the hypothesis and null hypothesis, which I know is kind of a handful to write there, but you don't have to do very many of these. Okay, state the significance level. This is 1%, so that's 0.01 is the significance level. Calculate the value of the test statistic chi-squared calc. That's going to be on the graphing calculator. Find the critical value, where the degrees of freedom is the number of categories minus 1. So this is something that is new. Okay, number of categories, 1, 2, 3, 4, 5. So that's going to be 5 minus 1 is going to be 4. So our degrees of freedom is going to equal 4. So now what you actually look at for this is you're actually going to turn to page 403 in your textbook, and we're going to look up our significance level and our degrees of freedom. So our degrees of freedom was 4. Right, and our significance level was at 1%. So where those intersect is at 13.28. Okay, so back here, on this here, the critical value is going to be, so chi-squared crit is going to equal, I think it was 13.28. Yep. Oops, sorry, equals 13.28. Okay, so that's going to be part of our little inequality here. So we want our chi-squared calculated to be greater than our chi-squared critical value, which we just calculated to be 13.28. 0.28, or actually looked up on the table, right? So what we got to figure out now is our chi-squared calculated. So we got to go back into our graphing calculator, and then away we go. Okay, so here's our calculator. So what we want to do is we got to get in and we want to put in this data here. So we're going to go into stat and then edit. And we are going to clear out our data in list 1 and in list 2. So again, to do that, highlight the list 1 or list 2, clear, and then once you go back down, it will clear the whole thing out. Okay, so remember the first one is the observed. So what numbers did we actually get? That's going to be these here. So we're going to do 25, 78, 77, 36, and 17. Okay, and then this next one, list 2, is always going to be the expected value. Okay, so there's 200. It was nice because they actually added these all up for us. So there's 233 possible. We expect 5% of those to be in this top column. So we're going to just do 233 times 0.05. So we expect 11.65 to be in the very satisfied. And then we expect of the 233, 25% of those to be satisfied. And then 233 times 0.41 for the next one. 233 times 0.2 and 233 times 0.09. Okay, and then just kind of double check your numbers to make sure that they at least look reasonable. It's getting bigger, but not crazy big. Yeah, these look like these are fairly reasonable numbers, okay? So this is what we observed. This is what we expect if these percentages hold true. That's the difference between list 1 and list 2, observed and expected. Okay, so let's take that info there and let's calculate stuff out. But first, let's take a quick little comedy break.
You're such a baby. Oh my God.
I love it. The cat lands on the dog's back and the dog doesn't even change anything, doesn't flinch at all. Anyway, okay. So we're going to go back into our chi-squared goodness of fit. So we're going to go into stat, and we're going to go over to test, and we're going to go down to chi-squared goodness of fit. So that's that funny looking X. There we go. We only got two options, chi-squared test and chi-squared goodness of fit. We're still under goodness of fit, so we're going to use that one. Okay. And let's, excuse me, observed is list 1, expected is list 2. And then our degrees of freedom on this one was 5 minus 1 was 4. So really all this is going to look exactly the same, whether it's critical values or not. It's just going to change what we put in for our inequality, our rejection inequality here. Okay, so we go through and calculate. And chi-squared is 28.75, so that is 28.75. Let's see. So that's really the only thing that's new in here. So we put 28.75. Is that greater than or equal to 13.28? So that is true. So since it's true, we now reject HO. So reject HO. Oops. H sub O. Which means if we reject HO, we got to take the other one. So accept H1, which basically says that if we go back to the original problem, it was asking when they changed stuff with their service, did it get better? Yes, it did end up getting better by a significant amount. Okay. Okay, so we can write there's sufficient evidence to support the ISP's claim that the changes were effective. Okay? All right, that's all we have for chi-squared goodness of fit. Second half here. If you have any questions on this, please feel free to ask in class. Thanks.